Hello learners, in this video we're gonna talk about factoring polynomials with common monomial factor. To get a good idea on what factoring polynomials is, let's take some time to review what factors are. Factors are numbers or terms that multiply together to get a product. So let's start with some basic examples. What are the factors of 6? 2 and 3 are factors of 6 because 2 times 3 is equal to 6. So 2 and 3 are the factors and 6 is the product. So aside from 2 and 3, what are other factors of 6? So 1 and 6 are also factors of 6 because 1 times 6 is equal to 6. So 1 and 6 are the factors and 6 is the product. Let's have another example. What are the factors of 20? 4 and 5 are factors of 20 because 4 times 5 is equal to 20. So 4 and 5 are the factors while 20 is the product. So aside from 4 and 5, what are other factors of 20? So 2 and 10 are factors of 20 because 2 times 10 is equal to 20. So in this case, 2 and 10 are the factors and 20 is the product. So aside from 2 and 10, what are other factors of 20? 1 and 20 are factors of 20 because 1 times 20 is equal to 20. So 1 and 20 are the factors and 20 itself will be the product. Just like numbers, algebraic expressions also have factors. So think of the term 6x. What are the factors of 6x? 6x can be factored into 2 and 3x because 2 times 3x is equal to 6x. So 2 and 3x are the factors and 6x is the product. Let's have another example. What are the factors of 8a squared? So 8a squared can be factored into 2a and 4a because 2a times 4a is equal to 8a squared. So 2a and 4a are the factors and 8a squared is the product. So aside from 2a and 4a, what are other factors of 8a squared? So you can think of a and 8a as factors because a times 8a is equal to 8a squared. So 8 and 8a are the factors while 8a squared is the product. So aside from a and 8a, what are other factors of 8a squared? You can even think of 8 and a squared as factors because 8 times a squared is equal to 8a squared. So these are the factors and 8a squared is the product. But what if we have the expression 8a squared plus 6a? This time we have a polynomial with two terms. In polynomials with multiple terms, sometimes each of the terms share a common factor. We call it the greatest common factor, or simply the common monomial factor. Now in this example, 8a squared and 6a share a common factor. 8a squared can be factored out as the product of 2a times 4a, and then we have a plus, so let's write here plus. And then 6a can be factored out as the product of 2a times 3. Now if you would notice, in the first term we have 2a, and in the second term we also have 2a. So 2a is the common monomial factor. Now we can write this again as the product of the common monomial factor and the remaining terms. So we can write it as 2a times 4a plus 3. So this is now the factored form. This is the factored form. So the process of factoring out the GCF, or the common monomial factor, is what we call factoring out the common monomial factor. In the next couple of examples, we will factor out each of the polynomials by factoring the greatest common factor, or GCF. Example number 1. Factor out the GCF in the expression 15a squared minus 10a. Now what we are going to do is we will determine first what is our GCF, or greatest common factor. So in the first term we have 15a squared, and then the second term is 10a. Look at their numerical coefficients, 15 and 10. You ask yourself, what is the largest number that can divide 15 and 10 without a remainder? So with a little bit of critical thinking, you will know that 5 is the greatest number that can divide 15 and 10 without a remainder. So we know that there is a 5 in the GCF. Look at the variables. We have a squared and a. So we know that we have an a in our GCF. Now usually we will choose the variable with the smallest exponent. So we write here in our GCF a. So our GCF is 5a. Next thing we will do is we will rewrite our terms with the GCF as a factor. So 15a squared can be written as 5a times 3a. And then we have a minus, so copy minus. And then 10a can be written as 5a times 2. So in this case, 5a is the GCF. So now we will rewrite this as the product of the GCF and the remaining terms. So we can write it as 5a times 3a minus 2. So this is now our answer. Example number 2. Factor out the GCF in the expression 24x squared y squared plus 18xy. So the first thing we do is we will identify our GCF, or the greatest common factor. Notice that in the first term we have 24, and then in the second term we have 18. So you ask yourself, what is the largest number that can divide 24 and 18 without a remainder? So a little bit of critical thinking, you know that's the number 6. So we know that we have a 6 in our GCF. Now look at the variables. In the first term we have x squared. In the second term we have x. So we will always choose the variable with the smallest exponent. So we know that there is an x in our GCF. And then in the first term we have y squared. In the second term we have y. So again, we will choose the variable with the smallest exponent. So we will choose y. So we know that we have a y in our GCF. So now 6xy is the greatest common factor for each of the terms. So now what we're gonna do is we will rewrite each term as having 6xy as a factor. So the first term can be written as 6xy times 4xy, and then we have a plus, and then the second term can be written as 6xy times 3. So notice that 6xy is the GCF. So now what we are going to do is we will rewrite this as the product of the GCF and the remaining terms. So we will rewrite it as 6xy times 4xy plus 3. So this is now our answer. Example number 3. We will factor out the GCF in the expression 15m cubed n minus 25m squared n squared. So the first thing we do is we will identify our GCF, or greatest common factor. Now, in the first term, we have 15, and then in the second term, we have 25. So you ask yourself, what is the largest number that can divide 15 and 25 without a remainder? So with a little bit of critical thinking, you know that that is the number 5. And then look at the variables. In the first term, we have m cubed. In the second term, we have m squared. So we will choose the letter or the variable with the smallest exponent. So we will choose m squared. We know that there is an m squared in our GCF. And then in the first term, we have n. In the second term, we have n squared. So again, we will choose the variable with the smaller exponent. So we will choose n. We know that there is an n in our GCF. So this is now our GCF, 5m squared n. So what we're gonna do now is we will rewrite each of the term as having the GCF as a factor. So we will rewrite 15m cubed n as 5m squared n times 3m, and then we have a minus, so right here minus, and then rewrite 25m squared n squared as having the GCF as a factor. So 5m squared n times 5n. So now 5m squared n is the GCF. So what we will do now is we will rewrite this again as the product of the GCF and the remaining terms. The GCF is 5m squared n times the remaining terms will be 3m minus 5n. So this is now our answer. Example number 4. Factor out the GCF in the expression 20x squared y plus 16x y squared minus 12xy. So what we're going to do now is we will determine first our GCF, or greatest common factor. Now notice that we have 3 terms here. In the first term we have 20, in the second term we have 16, in the third term we have 12. So you ask yourself, what is the largest number that can divide 20, 16, and 12 without a remainder? So with a little bit of critical thinking, you'll know that it is the number 4. So we know that there is 4 in our GCF. Now look at the variables. In the first term we have x squared. In the second term we have x. In the third term, we have x. So we will choose a variable with the smallest exponent, and that would be x. So now we know that there is an x in our GCF. And then in the first term, we have y. In the second term, we have y squared. In the third term, we have y. So again, we will choose the variable with the smallest exponent, and that is y. So we know that there is a y in our GCF. So 4xy is our GCF. Now what we will do now is we will rewrite each of the term as having the GCF as a factor. So 20x squared y can be written as 4xy times 5x, and then we have a plus, and then 16xy squared can be written as 4xy times 4y, and then we have a minus, and then 12xy can be written as 4xy times 3. So notice that 4xy is the GCF, right? So now we will rewrite this as the product of the GCF and the remaining terms. The GCF is 4xy times the remaining terms are 5x plus 4y minus 3. So this is now our answer. So that's it for our examples. Now for your activity, we have here 5 items for you to work on. If you find this video helpful, please do me a favor and subscribe, like, and also share the video so that we will be able to reach as many learners as possible. Also, do not forget to click the notification bell so that you will be updated whenever we will add a new video in our channel. Thank you for watching, and see you all soon on our next video.